Hi everybody. This is a video on solving higher order polynomials. These are going to be polynomial equations where we're going to have a focus on factoring. One of the reasons that we're focusing on factoring when we're solving these equations is it's a great way to connect what we already know to some new information. So I've got some steps for you. We'll put these into practice in a couple different videos. This is the first. The first step is we want to set every equation equal to 0. This is because of the zero product property, which we've talked about a lot before. Anytime things multiply together and equal 0, one of them has to be 0. After we do that, we're going to factor completely, to the best of our ability, down to prime polynomials. And then we'll set each factor equal to 0. Once again, that is the zero product property hard at work. One thing that's going to be a little new to you is that if there's a variable greatest common factor, so for example, 2x squared times x minus 1, the 2x squared is going to give us a solution or some solutions to, not just the x minus 1. Now, one thing that we're going to look out for to check all our answers is to make sure that our number of solutions matches the degree of the polynomial equation. The degree is the number of the highest exponent. Now, these solutions might be real, imaginary, or repeated. So, for example, we would get one real solution out of the parentheses x minus 1. We would get a repeated solution of x equals 0 out of 2x squared. That actually counts as two solutions because of that exponent there. All right, let's give one or two a try. I'll do the first one, and then you can join in and do the second one with me. So I'm going to start looking for a greatest common factor. I notice that 2 and 6 have a factor in common, and I notice that x to the 5th and x to the 4th have something in common. So the greatest common factor here is 2x to the 4th. If I think about undistributing that, that's going to give me x minus 3. Since this is an equation, and this is really important, we always have to remember that we have to keep that equal sign in there. There should be an equal sign following all the way throughout the entire problem. Okay, so we know from before, from all of our factoring in the past, to set x minus 3 equal to 0. So we get one solution of x equals 3. We may have known already, or we at least now know, to set 2x to the 4th equal to 0. Now when I solve that, I'm going to get 0. And this is the part where it gets tricky. This is called the fundamental theorem of algebra. This counts as 4 solutions. This one counts as 1 solution. The solution x equals 0 is repeated 4 times to fit in with the fundamental theorem of algebra that says the number of solutions matches the highest exponent. So 5 solutions. X equals 3 counts for 1 of them, and x equals 0 counts for 4 of them. So you should pause the video now, and you should attempt problem 2 on your own. And then I'll do that one for you. Did you pause the video yet? All right. So here goes. I'm going to set this equal to 0. 3x squared minus 12x equals 0. I notice that there's a greatest common factor here. That is, after all, what this whole page is about. And I'm going to factor out a 3x. That's going to leave me with x minus 4. I'm remembering still to keep that equal to 0 because this is an equation. I have to always have an equal sign in there. So my solutions for this equation are going to be x minus 4 equals 0, or x equals 4, and 3x equals 0, or x equals 0. Now in this equation, since our highest exponent is 2, or we have a second degree polynomial, each one of these just counts as one solution. All right, hope that was helpful.